Here we are with part 4 of the Math Analysis and Trig Summer Packet. This is part 4 because it's the fourth video, but it's technically part 5 as you can see here on your sheet. Let me get that stray mark out of here. Part 5 here on the packet. So we're dealing with exponents now. The first one is a -1 exponent. -1 exponent simply is a way to denote a term called the reciprocal. Reciprocal means you just take your fraction. Anything that is a numerator becomes a denominator. Anything that's a denominator becomes a numerator when the operation is multiplication. Alright, in this case we're multiplying everything down here, so this is a straight flip. It becomes x, y cubed, z, I believe that's a squared, over 2. So simplifying using no negative exponents. Simplify using no negative exponents again. Well, when you raise something to the 0, by definition that equals 1. So everything is raised to the 0. Again, simplify no negative exponent. So here I'm going to work inside my parentheses first. Typical order of operations, PEMDAS, right? Parentheses and then exponents. It really makes no difference here, but the nice thing is if I work in my parentheses first, I'll be making the things inside smaller so that when I do cube them, they won't be as big. So bottom line, 2 and 5 do not reduce, so that's still a 2 and a 5. My x's can combine. This -2 will jump to the top and combine with these 4 to make x to the 6th. These 3 y's, -3, right, jump to the bottom to make that y to the 8th. And the z's, there's 1 on top and 2 on the bottom, so they can reduce to just 1 on the bottom. And now we cube that, so 2 cubed is 8. X to the 6th times x to the 6th times x to the 6th. Remember, when you multiply exponents, you add them together. So when we raise to a power, we multiply them. So that's going to be x to the 18th. Over 5 cubed, 5, 25, 125. So 125. Y to the 24th. And z cubed. Excuse me. Number 4, same deal. We're multiplying here. So we have 3 times 4 is 12. X to the -1. So I'm actually going to write x to the -1 as over x. We end up with y to the 6th. Add the exponents, remember, and z, all volumes and lonesome. Inside the parentheses we can work. 3 is all by itself. X is, those 2 will jump up top, make that 7. Those 2 y's will jump down to the bottom, make that 7. And it's 2 to the -2. So the -2 means, first of all, flip your fraction, and secondly, don't forget to square everything. So I'm going to kind of do this all in one shot. The negative moves the 3 to the top, and the 2 makes the 3 a 9. The negative moves x to the 7th to the bottom, and it makes the 7 a 14. The negative moves my y squared to the top, and the 2 makes the 2 a 4. So it's 9y to the 4th over x to the 14th. Now moving on to radicals, which are technically exponents here, which is part 6. Simplify into radical form. Well, right off the bat I see 360 is the same as 36 times 10. X to the 10th is a perfect square. Y cubed, I'm going to write that as y squared and y, and z to the 7th, I'm going to write as z to the 6th and z. And now all the perfect squares, 36, x to the 10th, y squared, and z to the 6th, will come out in a different form. 36 becomes 6, x to the 10th becomes x to the 5th, y squared becomes y, z to the 6th becomes z cubed, and inside we're left with a 10, a y, and a z. Remember, a square root is equal to, so square root of x is equal to x to the 1/2. So if you want to think about raising x to the 10th to the 1/2, you want to multiply the 10 and a half, and there's where the 5th comes from there. Here we're on page 2, the cubed root of 108, x to the 5th, y to the 10th, z to the 12th. So now we need 3 of the same number. Well, 108 is 6 cubed, right? 6 times 6 is 36. And then 36 times 6 is 216. So yeah, never mind. It's not a not 6 cubed. 108, we need to think about that one for a little bit if it is even a perfect cube. I'm going to actually do a little bit of scratch work here because I'm not sure offhand if it is. 2 times 54, there's 108, which is then 2 times 27, which is then 3 times 9, which is then 3 times 3. So we right away have 3, 9, 27 times 4. 27 times 4, and 27 is a perfect cube, so I'm going to do 27 times 4. X to the third and an x squared, y to the ninth and a y, and z to the 12th is good how it is. Because remember, this is a 1/3 power now, so anything that goes into 1/3. So 27 cubed root of that is 3. We have an x, we have a y cubed, we have a z to the 4th, and left inside, I'm going to kind of change my color here so we can tell that's not an exponent, it's an index. We have a 4, an x squared, and a y left on the inside. Cubed root of x squared to the 4th. See if there's some directions hiding back here. I want to go to the previous page, see what the specific directions are in this section. Rewrite in simplest radical form. So simplest radical form for this one I don't think you can do anything. I mean, maybe you can argue that this is a simpler form. Looks good to me. Now this one certainly, and maybe that's where they're going here if we want to rationalize that problem. But this one we're certainly going to rationalize, multiply by the complex conjugate, which would be 3 plus root x and 3 plus root x, right? This is just nothing more than a fancy form of 1 that I've multiplied by. We're allowed to multiply anything by 1. So our new numerator is 3x root 3 plus x root 3x. Now the denominator, this is the important part, the denominator, this is like a difference of squares, right? 1's plus 1 minus, so we get a 9. Middle term cancels out. We have a negative 3 root x and we have a positive 3 root x, so they cancel out. But we end up with minus square root of x times square root of x, remember, is an x. So if you want to fool around with the numerator a little bit, maybe you can factor an x and a root 3 out, but I would probably just leave it as is. Nothing's going to cancel anywhere. So I mean, I'll leave this as one final form, or if you want to factor out an x and a square root of 3 from both, we'd end up with 3 plus root x and then over 9 minus x. Of course, nothing reduces there. So either one, in my opinion, would be fine. Same deal here, 1 plus 2 root 5 and 1 plus 2 root 5. So numerator, since we're multiplying by 1, is 1 plus 2 root 5. And denominator, you get 1. Again, middle terms cross out. But we end up 1 minus 2 times 2 is 4. And root 5 times root 5 is 5. So 1 minus 19, really. So we have 1 plus 2 root 5 over, 1 minus 20, which is negative 19. I'm just going to jump that negative to the top. And I'm going to write it like this. Typically, we put negative values, negative numbers in the numerator. Let's get a little solving in here. We'll go a couple more minutes on this video.